Hello everyone, today we'll talk about the problem maximal rectangle. We are given a rectangle consisting of zeros and ones. We're only interested in those positions which have a 1 on them and want to create the biggest contiguous rectangle consisting only of ones. So this would be a correct rectangle, this would be a correct rectangle, and this is the rectangle of area 6, right, consisting of 6 cells with ones, and this is the solution. Now, the very naive version, very naive idea, would be to iterate through all the upper left and lower left points and sum up how many ones are within that rectangle. Perhaps that can be made quicker by moving those coordinates in such a way that it's easier to update the current count. It would also be made faster if we calculated prefix sums, because of course the sum of this whole thing minus the sum of this minus the sum of this and plus the sum of this, since we've subtracted it twice, is exactly this area. So we can do it like that with prefix sums in constant time. We can check if a given rectangle is correct, but all those solutions are naive and too slow. Now, assuming we have prefix sums, we might as well indeed check every row for a position of our upper left, check every row for a position of our bottom right, check every column for the position of our, again, upper left. But now for the position of the bottom right, when it comes to columns, we know that we want it as far to the right as possible, so that the whole rectangle consists only of ones. And we can do it by binary search. And actually I think that with binary search and prefix sums, it'll be fast enough, because it'll be O of n to the third times log of n, and that's sufficiently faster than just doing it n to the fourth, especially since this is quite a simple algorithm, so there's not a big constant factor in it. There are many other ideas. For instance, we can start with every upper left vertex and try to create a rectangle of width 1, extending it as far as possible below. And then when we make it with 2, with 3, and so on, we might have to shrink it. And whenever we shrink it, because we don't have all ones of enough height, then it can never become higher. So essentially we're going to be going through some sort of a staircase, right? Or if we start here, then it can be this high, but now the only position is this, so we know we can end our check. So that'll also be fast enough to solve this problem. But we actually want to talk about an even faster solution, a solution that's actually only quadratic. And to do that, it is required for us to be able to solve a different problem, which is actually on LeetCode problem number 84. This one is 85, so it's not really well hidden, which is the largest rectangle in histogram. Because that problem asks us it gives us a histogram, and it asks us to give the area of the largest rectangle that can be created within it. So for instance, maybe this is the greatest one, or maybe this is the greatest one, or maybe this is the greatest one. Right, and we have to answer what's that area. And as it turns out, we can just simply utilize this very algorithm and go through all the, let's say, rows of our given matrix and just treat it like a histogram starting at that row. So for instance, if we're starting here, then the histogram would be, here it would include this one, then it will go down, up, down, yeah, it will be something like this. And indeed, the largest rectangle in this histogram is the one we've seen. So if we can solve this, let's say, one-dimensional problem, then we can solve our problem in quadratic time, since this one can be solved in linear time. Earlier today I've uploaded actually the solution to the largest rectangle in histogram, so if you don't know how to solve that problem, then I recommend that you watch the previous video. And now, assuming that you know how to do it, the code is really simple. We simply need to have a subroutine for calculating the largest rectangle area in histogram. We go through all the rows of our matrix, and what we maintain is the height of the current row. So we start with all rows of height, the height of the current position in our row. We start with all those equal to 0. So our histogram is just flat on 0. And whenever we want to add another row, let's say below, then if this value here is a 0, then our histogram still is a 0. And if this value is a 1, then our histogram is what it was previously, and one more. And this is exactly this line. So for every new row in our matrix, if we see a 0, then we take a 0 as the height, else we take the previous height and add 1 to it. Then we run our largest rectangle in histogram on that single row, and the maximum over all of those is the result. So the largest rectangle within this rectangular matrix of zeros and ones.